Hello, Mr. and Mrs. Bowen. We are looking at Albert's Skill Check 3. This is a new technique that I want to use to try to give you an idea of what he's doing and also work these problems out for you so when he brings these home, maybe you can finish them off or his tutor can. And either way, I'll post these so that you can see them privately, and we'll see if it works. Anyway, we worked on this today, and something to remember is this little saying called SADS when it comes to adding and subtraction with integers. If the signs are the same, you're going to add the numbers. If the signs are different, of course there's an E in there, you're going to subtract the numbers. Okay? So most people feel sad when they have to add and subtract integers. So SADS, here we go. So we have a negative 18 and a positive 5. So we're going to subtract those numbers. So if I subtract them, obviously I get 13. The number that's biggest is the number that gets the sign in the answer. So as you can see, Albert did that well. At first he didn't understand it, but I tried to break this down as simple as I could, and then he was fine. Here the signs are the same. We add the numbers, 19. The answer is negative, of course, because we have two negatives, and if their signs are the same, they stay. We have a 9 plus a negative 4. Essentially, that can be rewritten as 9 minus 4, which is a simple takeaway problem that leaves us with 5. As we can see, the biggest number is 9. The 9 is a positive. It doesn't have a sign in front of it. Therefore, it stays like that. 23 minus 18. Again, I told him as if they were opposite, you subtract the numbers. Or if they were different, you subtract them. And he did that here, got 5. The number that's positive, or the biggest number out of the two is 23. The 23 is positive, the answer is 5. Now here we come to another problem like we had over here where we had two negatives, the 7 and the 12. Here we have a negative 13 plus a negative 4. Well, since we have the same sign, we're going to add those two numbers, 17. And since they're both negative, we're on the negative side of the 0 on a number line. Therefore, they both get negative 17. Okay. Subtracting integers. Pretty much the same rules. It's just that we won't see plus signs in here. We're just going to see negative signs. But I told him a rule which we'll see in the other ones. We have a negative 11 minus 2. Well, the signs are the same. Therefore, we add the numbers. As you can see, most kids just want to take 11 minus 2, but they have to just understand that this is a negative number, which means we're on the negative side of 0, and we're going more negative, so therefore we're actually going bigger in numbers, and that leaves us with negative 13 here, which he understood. Now, this problem is negative 2 minus a negative 7. That's how that problem looked originally. We taught that whenever you have two negatives together, you're kind of really distributing the negative, almost multiplying a negative times a negative, and making it positive. So in a sense, it looks like negative 2 plus 7, which turns into a subtraction problem, 7 minus 2, which is 5. 7 is the bigger number, it's positive, therefore it stays positive 5. 5 minus 12. Again, write the biggest number on top when you're subtracting different signs. 12 minus 5 is 7, which he understood readily. And now we just have to make sure we finish it off. The bigger number is 12, and there is a negative to match the answer, therefore it's a negative 7. We had a 6 minus a negative 16. We made that a plus sign. We added the two numbers, 22. Nothing else needs to be done. Negative 7, negative 3. Actually, that reads negative 7 minus 3. Well, we got to add those two numbers. They're both negative, therefore the answer is negative, so negative 10. He's really good at multiplication. I just had to teach him whenever we have in multiplication, if the signs are the same, like a negative times a negative or a positive times a positive, it's always going to equal positive. And whenever you multiply a negative times a positive, you're going to always have a negative sign. So whenever the signs are different, the sign for the answer is always going to be negative. So let's look at this. 63, positive 63. 8 times 5 is 40. One of them is negative, therefore we have a negative 40. 7 times 4 is 28. Negative. So he got all the numbers right. He just really doesn't understand the negative and positive integers. But after we got through this, we did. So you can work with him on that. Dividing he gets. The same rules apply as multiplying. So negative 9 is the answer here. Positive 3. Anything multiplied or divided by 0 is 0. Negative 9. And here we have a, I'm not sure what we did here. This is a 13 divided by 1. He probably saw some addition or subtraction in there. That should be a positive 13 since we have two negatives being divided. Reducing fractions is really hard. I'm going to give you a quick tutorial here on a couple of them. We take the number that we can see that it can divide into, or a factor of the two. 2 is the easiest one to choose. So we're going to divide both by 2, which is like dividing the whole problem by 1, which doesn't change anything, which allows us to do this. 12 divided by 2 is 6. And 16 divided by 2 is 8. I can see that I can reduce that even more as a factor of 2. 6 divided by 2 is 3. 8 divided by 2 is 4. I can't break that down any further. Therefore, 3 over 4. 5, I'm just going to lose the division sign because it's kind of messy. I know that 15 goes into 5, and I know that 10 goes into 5, or vice versa. So 15 divided by 5, 5, 10, 15, that's 3. And 5, 10, 10 goes into 5, or 5 goes into 10 2 times. I can't break that down anymore, so that's my final answer. And here I choose the least common multiple of each, or you could say the greatest common factor, because we're looking for the highest number that goes into both. Here I'm going to choose 4. 12 divided by 4 is 3. 8 divided by 4 is 2. Therefore we have that. All right. And down here, the square roots usually give kids a problem. But the opposite of a square root is the square of a number. I know 2 squared is 2 times 2, which equals 4. So therefore, the square root of 4 must be 2. Okay, it's the number that it's multiplied by itself. 12 times 12 is 144. Therefore, the square root of 12, or 144, is 12. 225, big number. This is what I usually teach. If I said 10 times 10 is 100, and 20 times 20 is 400, then I'm actually in between somewhere these two numbers that I have. So what I'll teach is, let's just go, what's 11 times 11? And they'll have to work that out. 12 times 12, 144. So then they'll start seeing that there's a pattern, and they usually will get to eventually what the actual square root of 225 is, which is 15. Square root of 81 is 9, and the square root of 1 is 1. All right, let's go on to the next page, the bottom half of the problems, the page. Again, he usually doesn't get to these hard, difficult ones. We just did those. He can do the graphs. He really understands that well. All these are correct. -1 down 3. -1 up 2. Actually, he got this one wrong. You don't go left to right first. So there's 0, but we have to go up 3 now because this is the y coordinate and this is the x. So the point should have been up here. -2, 2, good. And 0, 0, perfect. All right, let's do the one-step equations. My main goal is to get x by itself. x by itself. So I'll have to do everything I can to get this stuff over here. Whenever I'm adding or subtracting, I'm just going to do the opposite sign. So if I subtract 8 on this side, I'm going to subtract 8 on this side. Since 8 minus 8 is 0, I'm just going to be left with x. And I have a negative 2 minus 8. Going back to our rules, same sign, you're going to add these numbers. Both of them are negative, so x is negative 10. Here I have a negative 7. I'm going to add the 7 on this side. I'm going to add the 7 on this side. I just draw a little line to separate the two. 7, a negative 7 plus 7 is 0, so I'm just left with the x. And since I'm adding over here, I'll just go ahead and put the sign. 17 plus 5 is 22. So x equals 22. Now, when we have a number that's next to it, this is neither addition nor subtraction. It is a division problem because 6 is being multiplied to x. They're close together. So, if they're multiplied 6 times x, I have to divide by 6 on both sides. 6 divided by 6 is 1. 1 times x is just x. 24 divided by 6 is 4. Since one sign is negative, it is a negative 4. Now, I have x divided by 4. Well, the opposite of division is multiplication, so I'm going to multiply this side by 4. That means I'll multiply this side by 4. 4 times 4 is 1. That leaves me with the x by itself. 8 times 4 is, oh my goodness, 32? I hope that's right. 32. And that's the answer there. Here it looks a little strange. We have the 4 over here, but that's okay. I know that's a positive 4. I'm going to subtract 4 on this side, and I have to do the same thing to the other side. X is by itself, since 4 minus 4 is 0. So I have 1 minus 4 over here. Different signs. Subtraction problem. 4 minus 1 is 3. So I know 3 is my answer. But which one's the biggest number? The positive or the negative? 4 is bigger than 1. My answer is actually negative 3. Okay. Order of operations. PEMDAS is the thing to remember. This can be taught more in depth later. I do have a video actually on PEMDAS. I'll share that with you guys. Parentheses, exponents, multiplication, division, addition, subtraction. Here we have a 10 plus 2 times 5. I have to do the 2 times 5 first. 2 times 5 is 10. Then I write down the rest of the problem. 10 plus 10 is 20. 3 times 3. Now the 3 is just in the parentheses, but this is actually a multiplication problem. So I'm doing the multiplication first before I do addition. 3 times 3 is 9, plus 2 equals 11. 11 is my answer. Now what's in parentheses is first 2 minus 6. The signs are different. It's a subtraction problem. 6 minus 2 is 4. The biggest number is a negative. The negative gets the sign. I keep that in parentheses because I have a 4 out here. Whenever I have a number attached to a parentheses, this is a multiplication problem. 4 times 4 is 16. One sign is negative, one sign is positive. The answer is negative 16. 2 cubed. 2 cubed means 2 times 2 times 2. I have to do that first. 2 times 2 is 4. Times 2 is 8. Plus 1 equals 9. 10 minus 5 squared. I can't do 10 minus 5. I have to do the exponent first. So, 10 minus 5 squared, which means 5 times 5. 5 times 5 is 25. Now I have a regular subtraction problem. These are two different signs, so I'm going to subtract 25 from 10, or 10 from 25, which leaves me with 15. My biggest number is 25. It has a negative, therefore my answer is 15. Distribute and combine like terms. Distributing is the process of taking what's in front of the parentheses and taking it to each thing in the parentheses as separated by an arithmetic symbol, such as positive or addition or subtraction. Let's see how this looks. 4x. We don't know what x is, so we just have to multiply 4 times x. 4 times negative 3 is negative 12. That's our final answer right there. We're going to distribute the negative 3, to both of them. Negative 3x, because it's negative 3 times x. And we have a negative 3 times a 16. Times 6, a negative 6. And that's going to equal 18. 6 times 3 is 18, last time I checked. And that's the final answer for that one. Distribute the 5. 5 times negative 2 is negative 10x. And we're going to distribute the 5 to the 25. Both are positive. I'm multiplying the two numbers, 10x plus 25. Now here's a little strange one. I got a 2 out in front, so I got to leave that 2 out here. And I'm going to distribute the negative 5 here and the negative 5 here. Distribute means I'm basically multiplying. So I have a negative 5x and a negative 25. Well, negative 5x needs to come out in front because I'm going to take this 2 and do something with the 25 since those are two integers. This is an integer with a variable. I can't mix them up. 25 is negative, 2 is positive. That's different signs, so I subtract the two numbers. The biggest number is a negative, so I'm left with 23. Negative 23. So that's my final answer. Negative 5x minus 23. And last but not least, the 4x gets distributed to 4, so it's 4 times x is 4x. The 4 gets distributed to the negative 3. That's 4 times negative 3 is negative 12. And on the outside of the parentheses, I have a positive 12. Well, I can just look at this. I can't do anything with the 4x. There's no other like symbols. And I have a negative 12, a positive 12, which equals 0. Those cancel out. That's my final answer. I hope this has helped. I know it's been a long video, but again, I'm using this. Maybe that all students can use this to check their work at home. But I specifically did this with Albert's paper so that you could see it. All right. Have a good night. Bye-bye.